Hello friend, I have already told you in my introductory video that the entire course is divided into 10 chapters. So in the first day and in the first week we are going to start module 1 of chapter 1. Chapter 1 is divided into 3 modules. So today we are going to start the first module, and also the module 1 is divided into 2 parts. So first we will start part 1 of module 1 of chapter 1. In this part, I shall give definition of partial differential equation, and I shall also classify that equation according to the nonlinearity present in that equation. So before going to the main slide, let me say a few words about the history of partial differential equation. The term differential equation arose after the pioneer work by Newton when he invented the laws of motion. He expressed the equation in terms of ordinary differential equation in 17th century. The study of partial differential equation started in 18th century in the work of Euler, D'Alembert, Lagrange and Laplace. They used partial differential equation as a tool to describe the phenomena observed in continuum mechanics. The partial differential equation was mainly used then for modeling of many physical phenomena observed in nature. Later on, after the work of Riemann, PDE is used in other branches of mathematics like differential geometry, algebraic geometry, topology, etc. The detailed history of partial differential equation can be found in any book related to history of mathematics. Now we are going to start the first slide of part 1 of module 1. Let me first define what is a partial differential equation. An equation involving 2 or more independent variables and one dependent variable and its all order derivatives is called a partial differential equation. Thus, the general form of a partial differential equation can be represented by equation number 1, where ux, uy, these are the partial derivatives with respect to x and y, and similarly we can define all other partial derivatives. Now, in equation number 2, we have shown some partial differential equations. So, these are the examples of partial differential equations. Now, we want to define order of a partial differential equation. The highest order derivative present in a partial differential equation is called the order of that differential equation. If you observe equation number 3, there are 2 equations. In the first equation, the highest order partial derivative is 2, and also in the second equation, the highest order partial derivative is also 2. So, equation 3 gives the examples of second order partial differential equation. Now, if we observe equation number 4, the highest order partial derivatives present in this equation is 3. So, this is an example of a third order partial differential equation. Now, according to complexity in a partial differential equation, we can categorize a partial differential equation into 4 categories. The simplest one is the linear partial differential equation. A partial differential equation is said to be linear if it is linear in the unknown function and all its derivatives. One example of a linear differential equation is given in equation number 5. So, if you see the coefficients of the derivatives in this equation, they are only function of x and y. So, this is a linear differential equation. Now, we shall define a quasi-linear differential equation. A partial differential equation is said to be quasi-linear if it is linear in the highest order derivative of the unknown function. The coefficient of highest order term may be function of independent variables, dependent variables and the lower order derivatives. One example of quasi-linear equation is KdV equation, which is written in equation number 6, and this is a third order quasi-linear differential equation, and this equation appears in plasma physics and in nonlinear dynamics. Now, we shall define a semi-linear partial differential equation. A partial differential equation is said to be semi-linear if it is linear in the highest order derivative of the unknown function, but there is a difference between a quasi-linear and semi-linear differential equation. In case of a semi-linear differential equation, the coefficients of higher order derivatives are only function of independent variables, but in contrast, in case of quasi-linear equation, the coefficient of highest order derivatives may be function of dependent variables and the partial derivatives of lower order. One example of semi-linear equation is written in equation number 7, and another example is also given in equation number 8, where del square is the Laplacian and which is defined as del 2 del x square, del 2 del y square, del 2 del z square. The equation number 6 appears in differential geometry. And the most complicated equation which does not belong to the earlier categories, that means the equation which is neither linear nor quasi-linear or nor semi-linear, that equation is called a nonlinear equation. A nonlinear equation is very complex and very difficult to solve. This is one example of nonlinear equation. So, in this part you have learned the definition of partial differential equation and its classification. So, there are 4 types of partial differential equation according to the presence of nonlinearity. But it is to be noted that though the linear PD is the simplest one, it is very difficult to solve a linear problem. In some few cases, in some particular cases, we can solve a linear differential equation, and in some few cases we can solve semi-linear equations, but finding analytical solution is impossible in most of the cases. For those cases, we use numerical analysis to find solution. You can learn this method in the course of numerical analysis. In this way, we end this part.